Okay, and welcome to this next video where we're going to look at Newton's second law, which builds upon the previous knowledge of Newton's first law with a different sort of emphasis, and it's really important that we understand the formula associated with Newton's second law going ahead into further work when we do pulleys, etc. So what is Newton's second law? Newton's second law of motion states, if the forces acting on an object don't balance, there is a resultant force which will cause the object to accelerate. The acceleration which this object will experience depends on the mass and is proportional to the resultant force. And this law is summarized by this formula, F equals ma. This law is used to calculate the weight of an object. Weight equals mass times g. Now I've got to add a couple more details to this, which are quite important. So I'll just read this again. If forces acting on an object don't balance, there is a resultant force which will cause the object to accelerate in the direction of the resultant force. Okay, so it's important to realize that there's an overall resultant force and the object will accelerate in that direction with this law. Okay, that the force, this resultant force, will be equal to mass times acceleration. And obviously we can extend that idea because weight is also a force, and extend the idea. We've got the mass times by acceleration, but in this case g, the gravitational acceleration due to gravity. So we can use this formula to find the weight of any object with a given mass. So let's have a look at example 1 and see how this works. So find the weight of an object with the mass 100 kilograms. So literally just do 100 times 9.8. Okay, and that will give you the weight of the object in newtons, 980 newtons. Part B. The weight of this object will be 5,000 times 9.8. Oops, sorry. 5,000 times 9.8, which will be 49,000 newtons. Okay, and when we look at forces, these we need to convert the mass into weight first in order to look at forces in depth. Example 2, find the acceleration object with this mass and it's acted on by resultant force of 60 newtons. So I'll invoke the F equals ma formula. The overall resultant force is 60, its mass is 12, and we want A. So our value of A will clearly be 5 meters per second squared. Okay. Right, example 3. Find the value of P and the acceleration of the 2 kilogram mass subject to the forces shown. So let's just break this down just a bit more. We need to find the value of P, which is this force here, and the acceleration of this 2 kilogram mass subject to the forces shown. Now we've got to understand that what the overall resultant force is. So the overall acceleration, it's not accelerating vertically. Okay, so if I look at the forces vertically, okay, then if I take R to be positive, because it's not accelerating vertically, that means we can say that P must be equal to 2g. Okay, 2g is the weight. The mass is 2 kilograms, so the weight will be 2 times g. Okay, so the value of P will be 2 times 9.8, which would be 19.6 newtons. Okay, now if vertically it's not accelerating, if vertically there's no overall resultant force, what's going on horizontally? Well, horizontally I need to think about what the resultant force would be. Okay, so if I take that the right direction to be positive, then the overall resultant force will be 10 minus 6, so 10 minus 4, which is 6 newtons. Okay, so there's an imbalance of forces here by 6 newtons, and that is equal to ma. Okay, m is 2, and we solve and we get an acceleration of 3 meters per second squared. Okay, so the most important part of this sort of question is to understand where is the resultant force, what is the direction of the resultant force. If there is no resultant force, then how can I find the value of P? And if there is a resultant force horizontally, how can I use that to find the value of A? Okay. There are some questions here where you can use the simple formula in the diagrams on page 164, exercise 10C. Now, you could be asked to do Newton's second law with vectors, and we're going to extend the ideas in the first video when we had Newton's first law. The forces given here act on an object of mass 5 kilograms. Find the acceleration, the magnitude of the acceleration, and the bearing of the acceleration. Okay, now if we've got these two forces that act on an object of mass 5 kilograms and there is an acceleration taking place, therefore we can say that the resultant force is equal to ma. Okay, so there is an overall resultant force. And how do we find the overall resultant force? If you remember from the previous video, we add the vectors together. Okay, so that's our overall resultant force, and that is going to be equal to ma. So 3I plus 2j is equal to ma, which is 5a. And we want the acceleration. We're going to give that as a vector, so we've got to divide through by 5. So you get 3 over 5i plus 2 over 5j. Or you can write it as a fifth, 3i plus 2j. Meters per second squared. We have to ensure we give the correct units there. Okay. Right. So that's how we find the acceleration using Newton's second law in vectors form. Okay. So again, I'll find the resultant force by adding the vectors together, and obviously there is an acceleration, so we can use F equals ma. Right. Now part B, find the magnitude of this acceleration. So again, we're going to use the Pythagoras of the vector to give us the magnitude of acceleration. So we've got to do 3 over 5 squared plus 2 over 5 squared to get 9 over 25 plus 4 over 25. Okay, and we square root that, you get root 13 over 5 meters per second squared. And if you evaluate that, you get 0.72 meters per second squared. Okay, so that is the magnitude of acceleration. And the bearing of this acceleration, again, doing a quick diagram will help us to illustrate this. It's 3 over 5i plus 2 over 5j. So it's going to look like this: 3 over 5 long, 2 over 5 up. Okay, and we want the magnitude of the bearing, so it'd be good to get this angle here, which we can do with this. Tan theta equals opposite over adjacent, 2 over 5 divided by 3 over 5, which you get 2/3. You get an angle of theta to be 33.7 degrees. But obviously you want the bearing, which is from the y-axis, so you've got to do 90 minus that, which is 56.3 degrees. Okay, so that's how we use Newton's second law with regards to vectors in example 4. Extend this idea for the final video, for the final example. Again, we're going to use the same sort of concepts, except we've got it in column vector form. So we've got two forces acting on an object of mass 3 kg, which is initially at rest. Okay, so that means the initial velocity is equal to 0. I mean to find acceleration. So if there's an acceleration, that means there's an overall resultant force, and therefore I can use Newton's second law. The resultant force will be the total of these two vectors, 6 minus 3. Okay, so that's the overall resultant force, 6 minus 3, and that's equal to ma, which is 3a. Therefore the acceleration vector will be a third of 6 minus 3, which will be 2 minus 1, which you can write as 2i minus 1j. Okay, so that's the acceleration as a vector, meter per second squared. How do you find the magnitude of acceleration? Again, like we've done before, we've got to do the Pythagoras of that vector. So 2 squared plus minus 1 squared, which is root 5 meters per second squared. Okay, and obviously if I want to find the value of root 5, it will be 2.23 meters per second squared. Right, part C, bearing of the acceleration. I'm going to draw a little diagram. So 2i minus 1j, it's going to look like that. To get the overall bearing, it will be useful if I can get this theta again. So tan theta equals 1 over 2, opposite over adjacent. (26.565), etc. Okay, but remember we need to add 90 to this, and we'll get the overall bearing, which is 116.6 degrees. Right, part D, the time taken to travel a distance of 50 meters. Right, this is where we've got to think very carefully. None of what we've learnt so far with F equals ma or whatever gives us time. We've got to think, we've got these forces acting on this object of mass 3 kg. It's acting, the mass is initially at rest, so U is equal to 0. We want the time taken to travel a distance of 50 meters. So it's beginning to look like a SUVAT question. Okay, we don't really know what V is, we don't want it. We've got an acceleration of root 5 and we need time. Okay, again, we don't really want velocity, final velocity. So we've got to think of a formula which links up S, U, A and T. Okay, so one that comes to mind immediately is S equals UT plus half AT squared. Okay, 50 equals 0 times time plus half root 5 t squared. So yeah, 50 equals root 5 over 2 t squared. Okay, so 50 times 2. 50 times 2, then divided by root 5. T squared is equal to 20 root 5. Therefore t is equal to the square root of that, which is 6.69 seconds to 3SF. Okay, that's the final answer. So that was a question where we use Newton's second law, and we use SUVAT as well because we are thinking about it as constant acceleration. Right, that's the end of Newton's second law, and there are some questions here on this page which are well worth having a look at. Again, the main sort of things to understand is if there is acceleration, then Newton's second law states that this has to be the case, and you will have to find resultant force, use the mass, and see if you can find acceleration amongst other things in vector form and in diagram form. That's the end of the video.